we will talk about electricity and electric current. We will have a piece of wire which is made of copper. Copper is like any substance. It's formed from atoms. Each atom is formed from the nucleus, which is found in the center of the atom. This atom contains positively charged protons and neutral neutrons. The nucleus is surrounded by negatively charged particles, which are called electrons. But we haven't discovered this in the beginning. So in the beginning, when we were dealing with electricity, we thought that there is a charge which is moving inside the wire. And we assumed that this charge is positive, which we discovered later that it's wrong because the particle which is moving through the wire is the negative electrons, not positive. So if this wire is connected to a battery, and the battery is like a pump, it will push this charge through the wire. So this positive charge will repel with the positive of the battery, and it will move away from it, and it will be attracted to the negative terminal of the battery. So in this case, a current will flow in the clockwise direction. But this is called the conventional direction of current. This is not the actual direction of current. Because later we discovered that the particle which is moving inside the wire is not positively charged. It is negatively charged particle which is called electron. So according to the new discovery, this electron will be attracted toward the positive terminal of the battery, and there will be a repulsive force between the electron and the negative terminal of the battery. So in this case, the actual direction of the flow of the electrons will be in the anti-clockwise direction. So the actual direction of the flow of the electrons is in the opposite direction of the conventional direction of the electric current. So what's meant by electric current? Electric current is the flow of electric negative charges, which are electrons, through a conductor. So if we have a conductor, this conductor contains free electrons, free charges. When these free charges are moving, then we have electric current, like in this video. This is the conductor. This conductor is formed from atoms. Each atom is formed from the positively charged nucleus, surrounded by electrons, but we have many atoms. We are interested in the electrons which are found in the outermost energy level. In conductors, the attraction force between these electrons and the nucleus is very weak, so they can move from one atom to the other. So the flow of electric charge in this case will form an electric current. So if we have static electrons, we don't have electric current, but if we have charges that can move, we have electric current. So this can be done if we have a battery, because a battery will create something which is called potential difference. It will make one of the terminals having higher potential than the other terminal. So the current will flow from the high potential to the low potential. This is the copper atom. Can you see? This is the outermost electron. Its attraction force with the nucleus is weaker than the other electrons, so it can move randomly through the copper conductor. And the copper conductor, the piece of conductor, contains millions of atoms. So if we have a battery, this is the positive terminal, the current will flow in the clockwise direction. But the current is based on the assumption that we have a positive charge that can flow. Later we discovered that the charge that will flow is the negative electron. So the negative electron will move from the negative terminal of the battery to the positive terminal of the battery. So in the anti-clockwise direction. This is the flow of electrons, okay? So we have two methods for describing the electric current, the direction of the electric current. The oldest method, which is commonly used, which is called conventional direction of current. And we have another one, which is called the actual direction of current. What's meant by conventional direction of current? The current direction is from the positive terminal to the negative terminal outside the electric source. This is the electric source, which is cell. Now we have a battery. So the current will move out of this source from the positive to the negative. But inside the source, it will flow from the negative to the positive. This is based on the assumption that we have a positive charge that flow through the conductor, which we discover later this is not correct. But what's meant by the actual direction of current? The electron's direction is from the negative terminal. Can you see the opposite? The negative terminal to the positive terminal outside the source. This is the source, this is the cell, this is the battery, this is the electric resistance. If we are talking about the movement of electrons, electrons will move from the negative terminal of the battery to the positive outside of the source, but inside the source from the positive to the negative. So we have a closed path. So this is the actual direction of electrons. So the motion of the electrons are or is in the opposite direction of the movement of current. So if the current is moving clockwise, the actual movement of electrons is in the anti-clockwise direction, and so on. But what's meant by electric current intensity? Electric current intensity is the quantity of charge in coulomb, which passes through a conductor in 1 second or in unit time. This is what's meant by electric current intensity. There is a difference between electric current and electric current intensity. Electric current, we have electric charges that can flow, that can move. But electric current intensity, it means the strength of the electric current. What is the value of the quantity of charge that passes through the conductor in unit time? So this is called electric current intensity, which is measured in ampere. So what's meant by electric current intensity, and its symbol I, and its measuring unit is ampere. It is the quantity of electricity, which is Q, in coulomb. This is the measuring unit of the quantity of charge, or the electric charge flowing through a cross-section area of conductor in 1 second. This is the measuring unit of time, 1 second. So this is the first formula that we'll have. We will have I is equal to Q over T. So here you divide, but if you have them beside each other, you multiply. So what if you want T? Just cover it by your hand, it will be equal to Q over I. What if you want to find Q? Then you multiply I times T. So here you will have a number, its measuring unit will be ampere. This number, its measuring unit will be second. This number, its measuring unit will be coulomb. So the measuring unit of the quantity of charge is coulomb, time second. Electric current intensity, it is in ampere. So what's meant by ampere? Ampere, it is the measuring unit of the electric current intensity. So it is the electric current intensity, which is equal to Q over T. So what's meant by ampere? It is the electric current intensity when a quantity of charge of 1 coulomb passes through a conductor in 1 second. What does it mean? If you have a wire and the quantity of charge which is passing through this conductor is 1 coulomb in 1 second, then in this case the current intensity is equal to 1 ampere. What if you have only half coulomb and this half coulomb is flowing through the conductor in half second? In this case also you have 1 ampere, because half coulomb divided by half second is equal to 1. What if you have 2 coulombs that passing through the conductors in 2 seconds? Also Q is 2, T is 2, so 2 divided by 2 is 1, which is 1 ampere. So what's meant by ampere? Ampere, it is the electric current intensity, which is I, which passes through a circuit when a charge, which is Q, of 1 coulomb passes through a given cross-sectional area in 1 second, which is time. So we have a battery, and this green dot represents electrons. Electrons flow from negative to positive. 1 coulomb is approximately equal to this huge number of electrons that passes per 1 second. And by the way, we can calculate this. We will calculate it right now. What's meant by coulomb? Coulomb, it is the measuring unit of quantity of charge. And according to this relation, quantity of charge is equal to I times T. So what's meant by coulomb? Coulomb is the quantity of charge. when passed through a cross-sectional area of conductor in 1 second, it will create a current of intensity of 1 ampere. This is the definition. So what's meant by Coulomb? It is the quantum charge, which is Q, that when passed through a cross-sectional area of a conductor in 1 second, this is time. It produces electric current intensity, this is I of 1 ampere. So now time is equal to 0. This is the number of electrons that flow in just 1 second. So if you count the number of these electrons and you multiply it by the charge of 1 electron, which is a constant number, which is equal to 1.6 times 10 power negative 19, in this case you will get the total charge, and in this case it will be 1 coulomb. So I is equal to Q over T. So if the quantity of charge is 1 coulomb and the time is 1 second, so in this case the electric current intensity is 1 ampere. Done. So to calculate the total charge, you need to find the number of electrons and to multiply this number by the value of the charge of each electron, which is the same for all electrons, in coulomb. So since I is equal to Q over T, and now we have discovered the total quantity of charge is equal to the charge of 1 electron times the number of electrons divided by T, how can we calculate the number of electrons? We just do cross multiplication. I is equal to N times E. This small dash represents it is a negatively charged particle over T. So we'll do cross multiplication. I times T is equal to IT. 1 times N times E is equal N times E. We will divide this equation by E. So the number of electrons will be equal to I times T over E. So we can calculate the number of electrons just by multiplying the current intensity times the time divided by the charge of electron, like in this formula. How can you use this formula? Just you cover this one, which is I, and you write these two first, N times E divided by T. What if you want to find T? Then you will cover it first, and you multiply N times E divided by I. What if you want to calculate N? You need to just start with this one because we have I times T. This is according to cross multiplication divided by this one, which is E. What if you want to calculate the charge of electron, which is already constant? You just cover it, then you write these two numbers or variables first divided by N. Here you will have a number and its measuring unit is ampere. Here the measuring unit is second. Here it's just a number, so it's electrons. Here it's just a charge, so its measuring unit is coulomb. How can we measure the intensity of current directly without calculations? We measure it by using a measuring device, which is called a meter. A meter is a device with very low resistance. Its resistance very small, which can be neglected, which is connected in series. Series means we have a battery and we have a branch, and in this branch, directly in the main branch, we will connect this ammeter, and this ammeter will be followed by the resistor and the rest of the components of the circuit. This is called series connection because each component is connected one after the other. This is called series connection. So why ammeter is connected in series? So the same value of the current intensity will pass through it. So ammeter is connected in series in the electric circuit. Why? To measure the electric current intensity. Like in this video, we have a battery, we have a bulb, and we have this ammeter which is connected in series. You will have a circuit like this circuit, and you will be asked just to draw the ammeter. Then you need to calculate the ammeter in series. What's meant by series? Means in this branch you will add it. You will not create another branch, only the same branch. Let's answer some questions. An electric current of intensity, this is the symbol of electric current intensity, is 5 milliampere. We need to convert it. To convert it from milliampere to ampere, you need to multiply by 10 power negative 3 because current intensity should be in ampere. So it will be 5 times 10 power negative 3 ampere. So the electric charge, the symbol of electric charge is Q. The passes through a definite cross-section area of conductor or of wire in 10 seconds is equal to what? Okay, you know that we have a formula in which I is equal to Q over T. So if you want to calculate Q, you just multiply I times T. We have I after conversion, it's 5 times 10 power negative 3, and time is equal to 10. So this one is equal to 5 times 10 power negative 2, which is equivalent to 0.05, and its measuring unit is coulomb. So this is wrong, this is right, wrong, wrong. So the answer is B. We have another question. If the current intensity is 5 milliampere, so you need to multiply it by 10 power negative 3 to convert it into ampere. Then the number of electrons that pass through a cross-sectional area in the same time. The same time is 10 seconds. So you have two options. Just use this formula, which is N times E is equal I times T. So N is equal to I times T over E. And the charge of electron is constant. Or you can just use this formula, which is U, total charge, is equal to the charge of one electron times the total number of electrons. And we have calculated the total charge from the previous question. So Q is equal to 0.05 coulomb. So to calculate the number of electrons, you just divide the total charge divided by the charge of one electron. The total charge is 0.05. The charge of one electron is equal to 1.6 times 10 power negative 19 coulomb. So the total number of electrons in this case is equal to fraction 0.05 divided by 1.6 times 10 power negative 19. So it's equal to 3.125 times 10 power 17 electrons. So in this case, the answer is D. For this question, the graph below shows the relation between the electric charges flowing in a conductor and the time this takes. The current in this case is equal to what? As you can see, in the y-axis we have quantum charge in coulomb, and over the x-axis we have time in seconds. And as you know, the electric current intensity is equal to Q over T. So it's equal to y over x, or delta y over delta x. This is the slope. So if we calculated the slope of this graph, we actually calculated the electric current intensity. So the slope in this case is equal to delta y over delta x. So the final point, it's 25 minus the initial point is 0, and make sure it is in coulomb. The final point on the x-axis is 10 minus the initial point is 0, and make sure that it's in seconds. So it's 2.5 divided by 10. No, it's 25 divided by 10 is equal to 2.5. And the unit will be ampere because the slope represents the electric current intensity. So the answer is D. For this question, the opposite graph represents the variation of the electric current intensity I through a conductor versus time t. Then the electric charge that has passed through a cross-section area of conductor during the represented time interval, which is 10 seconds, is equal to what? Now, the value which is drawn on the y-axis is current, and that which is drawn on the x-axis is time. And you know that Q is equal to I times T. So I is drawn on the y-axis, x is drawn on the x-axis, so you want to have y times x. This is not the slope. This is called area under the graph. So if you have a current intensity time graph and you were asked to calculate the quantum charge, you need to find the area under the graph. How can we find the area under the graph? We need just to divide this shape into two shapes. Can you see? This rectangle, we will try to find its area. Followed by, we will find the area of this triangle. How can we find the area of these two shapes? And the summation of these areas will represent the quantity of charge. So first, we will calculate the area of rectangle, which is equal to length times width. Its length, it extends from 0 to 10, so it's 10, times its width, it extends from 0 to 2, so it's 2. So 10 times 2 is equal to 20, and since this represents a charge, it's coulomb. How can we calculate the area of triangle? Area of triangle can be calculated by multiplying half times base times height, or base times height divided by 2. Half times, what is the value of the base? It extended from 0 to this point. This point is 4. Times, what is the value of height? Height, it extended from 2 to 4. So 4 minus 2, it's 2. So you can cancel 2 with 2, so it will be 4. 4 coulomb. So the total charge in this case will be equal to 20 coulomb plus 4 coulomb, so it will be 24 coulomb. So the answer is B. I told you before that a potential difference is needed in the circuit, so we have a continuous flow of the electric charge. Why? You can see this video to understand. Can you see the water flow in the container to the left? This is due to the high pressure. We have a high pressure. We have a pressure difference. And as you can see, here we have high pressure. This reading is higher than this one. This is the reason that we have more flow of water molecules from the container to the left more than that to the right. So this pressure is exactly similar to that of the battery. Can you see? We have a battery, its electromotive force, its pushing force is 1.5. But we have another battery, its electromotive force is 9 volt. Can you see? The brightness of this lamp to the left is less than the brightness of the lamp to the right, because here the electrons are pushed with higher potential. So they have more energy. So the brightness of the lamp in the circuit to the right is higher than the brightness of the lamp in the circuit to the left. So this battery is making this terminal to have a potential more than this terminal by 1.5. But this battery is giving this terminal a potential more than this terminal by 9 volt. This is what's called by potential difference. So what's meant by potential difference? Potential difference is equal to W over Q. This is the potential difference which is measured in volt. This is the work done by the battery, and it is measured in joule. This is the quantity of charge which is pushed by the battery, and its measuring unit is coulomb. So what's meant by potential difference? Potential difference is the work done to transfer quantity of charge between 2 points having potential difference. So what's meant by potential difference between 2 points? It is the value of the work done to transfer a quantity of charge. So the work done is W. To transfer quantity of charge is Q. Its value is 1 coulomb between these 2 points. For example, we have Q1. It has lower potential. So you need to give it higher potential. So you need to exert work on it. So a work should be done on it. So this work will be stored in the charge as potential energy. So to calculate the potential difference between 2 and 1, you need to do V2 minus V1. And since the potential of V2 is higher than the potential of V1, so this difference will be positive. But if you are trying to find the difference between V1 and 2, so it will be V1 minus V2. So this is smaller than this one. So the difference in them will be negative. This is called potential difference. But V1, it's called the potential of the charge in position 1. V2, it's called the potential of the charge in position 2. But V21 or V12, it's called the potential difference between the two positions. So the potential difference, which is symbolized by V, is equal to the ratio between the work done and the quantity of charge which needed to be transferred. The measuring unit of work is joule. The measuring unit of the potential difference is volt. The measuring unit of the quantity of charge is coulomb. What's meant by volt? Volt is the measuring unit of the potential difference, and potential difference equals the work done over the quantity of charge. So what's meant by 1 volt? It is the potential difference between 2 points. For example, point A and point B. If the potential difference between point A, this is the direction of the current. This is the voltmeter, which is a device which is connected in parallel to measure the potential difference. If the reading of this voltmeter is 1 volt, this means that it is the potential difference when a work of 1 joule is needed to be done to transfer quantity of charge of 1 coulomb between the 2 points, which are A and B in this case. So what's meant by volt? It is the potential difference across 2 terminals of conductor, for example A and B, on doing a work, which is W, of 1 joule to transfer quantity of charge, which is Q, of 1 coulomb between these 2 points. What if you are doing a work of 2 joule and the quantity of charge is half coulomb? So in this case, the potential difference is equal to work over Q. So it's equal to 2 divided by half. So it's equal to 4 volt. So this means that the potential of this point is higher than this point by 4 volt. For example, if this is 4 volt and this is 0, so this is 4. But what if this is 10, this is 14? What if this is -2, this will be 2, because 2, -2, it will be 4. So the potential of this one will be higher than the potential of this one by the reading of voltmeter, which is the potential difference. The name of the device that we are using to measure the potential difference is called voltmeter, and it is connected in parallel. For example, you will be asked to measure the potential difference between the terminals of resistor X, for example. This is X, this is Y. So in this case, you will draw a voltmeter, a circle that contains V, and it has 2 terminals, and you will connect the 2 terminals with the 2 terminals of the resistor, which in this case X, because I'm asking you to find the potential difference between the 2 terminals of X. So this type of connection is called parallel connection, and it is connected in parallel because this point has a potential, for example, which is A, and this is empty wire, so the potential stays the same. Here we have passed through a resistor, so the potential decreases and change to be B. B means a number. For example, this is 10, for example, this is 4. So the potential of this one will be also B, because this is an empty wire. Can you see? Now the voltmeter is measuring the potential difference between A and B, which is exactly the potential difference between the 2 terminals of the resistor X. What's meant by electromotive force? Electromotive force, it is also the potential difference. So it is also the work done over quantity of charge, but this is the work done by the battery. So the electromotive force is the work done by the battery to transfer a quantity of charge of 1 coulomb through the whole circuit and inside the battery as well. So what's meant by electromotive force? It is the work done to transfer an electric charge of 1 coulomb through the whole circuit. And the whole circuit means in the external circuit and inside the battery as well. So the potential difference is needed to have a continuous flow of electrons and to have an electric current. So if you have a resistor and the potential of this one is 10 volt and the potential of this one is also 10 volt, in this case no current will flow, and in this case the current intensity will be 0. But what if you have a resistor and the potential of this point is 5 and the potential of this point is 2? So the current will flow according to the conventional direction of current from the high potential to the low potential. What if you have a resistance and the potential of this one is 5, but the potential of this one is 10? So the current will flow from the high potential to the low potential, so it will flow from 10 to 5 and so on. In this question, the opposite circuit contains 2 devices, one is X and the other is Y, that are connected correctly. So which of the following choices represents the measuring units of the quantity that is measured by the device X and the measuring unit of the quantity that is measured by device Y? First of all, can you see the current is flowing from this battery, passing through this resistor, then passing through this device, then coming back to the battery. So device Y is connected in series. So this device represents a meter, because a meter is the device which is connected in series. And this device is used to measure the electric current intensity, which is measured in ampere. And as you know, I is equal to Q over T. And the measuring unit of Q is coulomb. The measuring unit of time is second. So ampere is equivalent to coulomb over second, or coulomb per second, or coulomb dot second power negative 1. So the device Y is measuring electric current intensity in unit called ampere or coulomb per second. So this is Y. Volt, wrong. Ampere, true. Wrong, true. So the answer is B or D. What about device X? Can you see? This point has a potential, which is A, for example, which is high potential because it is connected to the positive of the battery. And this is an empty wire. So this point has also the same potential. This point is connected to the negative of the battery, so it has low potential. And this is an empty wire, so the potential is B. So can you see? This device, its two terminals are exactly the same two terminals of the battery. So this is called parallel connection. So X is a device which is connected in parallel. The device which is connected in parallel is voltmeter. And it is a device which is used to measure the potential difference or the electromotive force of the battery, which is also a potential difference. So V is equal to W over Q. The potential difference is measured in volt, which is equal to W over Q. W is measured in joule, Q is measured in coulomb. So volt is equivalent to joule over coulomb, or joule per coulomb, or joule dot coulomb power negative 1. So this is wrong, this is wrong, this is right, this is right. So the correct answer is D. We have very important experiment which is called Ohm's experiment, in which we have a battery, because battery is the pumping source. It will push charges. So we have a moving charge, so we have electric current. Then we have something which is called rheostat. Rheostat means a resistance that we can control its value by changing the length of the wire in the circuit. This is called slider. And this component is called rheostat or variable resistance. It's called variable resistance because we can change its value. Then we need to measure the electric current intensity. So we need to calculate a device which is called a meter, which is connected in series. Then we need to have a lamp. This is the symbol of lamp or bulb. Or we need to have just a device which has a fixed resistance. Then we need to close the circuit or control opening and closing it. So we have a switch, but in this case, this one is called open switch. So in this case, the current is not flowing, right? So we need just to close this switch. So in this case, we have a closed switch. So the current will flow in this direction. But also we need to measure the potential difference between the terminals of this resistance. So we'll draw a voltmeter, which is connected in parallel with the resistance only. And we will just create a table. And we will try to change the voltage each time. And in each time we will try to calculate the corresponding current. Or we can just, we can do this. We can have a battery, and this battery is connected to a meter, then a resistance without rheostat. And we have a battery of a changeable electromotive force. We can change its electromotive force. We can just increase it or decrease it. So if the electromotive force is 0, the current is 0. If we increase it to be 10, the current may be 5. If we increase it to 20, the current will be 10. To 30, the current will be 15, and so on. 40, the current will be 20. So in this case, we can calculate the value of the resistance. Or we can have a battery of constant electromotive force, but we can add a rheostat by which we can change its value. So when the value of the resistance changes, the current in the circuit changes. And we will draw the relation between I and V. So as you can see, the values of V is 0, 10, 20, 30, 40. And the values of the current are 0, 5, 10, 15, and 20. So the first order pair, of course, this is not 0, it's not from here. This is 0, so this is 5. 0, 5, 10, 15, and 20. So the first order pair is, we start with V, so 0 and 0. The second order pair is 10 and 5, 20 and 10, 30 and 15, 40 and 20. So we'll have a straight line. So the slope of this straight line, how can we calculate the slope? The slope is equal to the change in y-axis divided by the change in x-axis. So this means that the change in the current divided by the change of the voltage. This one is equal to exactly 1 over R. This is called the reciprocal of the resistance, because we discovered that the resistance is equal to the ratio between V over I. This is called Ohm's law. But on one condition, the temperature is kept constant. Because if the temperature is not kept constant, this graph will not be a straight line anymore. It will be a curved line. Because when you increase the temperature, the electrons will gain extra kinetic energy. So the value of the resistance of the wire will change. It will not remain constant. So for Ohm's law to be valid, you must keep the temperature constant. So this is the circuit. We have a battery just to push the electrons. We have a rheostat or variable resistance to control the value of the current in the circuit. This is the fixed resistance of our device. This is the voltmeter, which is connected parallel to measure the potential difference between the two terminals of the resistance. This is the ammeter, which is connected in series to measure the electric current density. If we have a voltage time graph, pay attention, this is voltage time graph, not current voltage graph. So the straight line with the highest slope will have the highest resistance. So this is 1, this is 2. In this case, the resistance of 1 is higher than 2. Why? Because the slope of 1 is more than that of 2. But on one condition, to be V over I. Why? Because the slope in this case is equal to V over I, which is equal to R. But what if we have a relation between I and V? And this is the first graph, and this is the second graph. In this case, the resistance of 2 is higher than that of 1. Why? Because the slope in this case is equal to delta y over delta x. And as you can see, this is a smaller slope. But this one is equal to the reciprocal of the resistance. So if you are searching for the biggest resistance, you need to find the smallest slope. So this graph is exactly the opposite to this graph. So according to Ohm's law, V is equal to I times R. You need to pay attention to this formula, because by using this formula, you can solve almost all the questions related to electricity in your syllabus. So V is equal to I times R. If you want to find R, you just cover it. It will be V over I. If you want to calculate I, just cover it. It will be V over R. Here you will get a number. Its measuring unit is ampere. Here you have a number. Its measuring unit is ohm. Here you will have a number. Its measuring unit is volt. So the measuring unit of potential difference is volt. Current intensity is ampere. Electric resistance is ohm. And the symbol of ohm is like this, omega. So what's meant by Ohm's law? Ohm's law states that the electric current intensity passing through a conductor is directly proportional to the potential difference, but on one condition: you must keep the temperature constant. If the temperature changed, the resistance also will change. So what's meant by Ohm's law? The electric current intensity, I, which passes through a conductor, is directly proportional. Directly proportional means if you increase the voltage, current will also increase. If you decrease the voltage, current also will decrease. Is directly proportional to the potential difference across it on one condition: at constant temperature. What if the temperature is not kept constant? Can you see? The number of collisions will increase, and the friction between electrons and atoms and nucleus and whatever, anything that will face the electron that it will collide with will increase. So the temperature will increase. So the loss of energy will increase. So in this case, resistance has increased. So what's meant by resistance? It is the opposition. Opposition means the current is moving in one direction and it faces a resistance that an electric current faces during its passing through a conductor. Or what's meant by resistance? It is the ratio between the potential difference, which is the reading of voltmeter, between the two terminals of a device and the current intensity passing through it. So this device is connected in series to measure the current. This device is connected in parallel to measure the voltage. So what's meant by electric resistance? It is the ratio between the potential difference across the two ends of a conductor in volt and the electric current intensity passing through it in ampere. We have two types of resistors. We have a resistance of fixed value. This is its symbol. This is called fixed or constant resistance. But we have other resistance that we can control its value. It's called variable resistance or rheostat. By the way, you can change the value of this resistance manually or by using other factors. There are other resistors that you can change its value by changing temperature, by the change of the light intensity, by the change in the voltage, by the polarity of the voltage, and so on. But overall, it's still variable resistance because you can control its value. But we have other resistors which are constant, fixed. They can be changed. Can you see? This is a bulb in which current will flow through it, but its resistance will increase because the temperature increases. So it doesn't obey Ohm's law, because when the temperature increases, the number of collisions increases because electrons gain extra kinetic energy and their velocity increases. So explain, the rise in temperature increases the resistance because the kinetic energy of atoms increases, and this increases the collisions. Collisions mean they collide, they hit each other. Between them increases, so the resistance of the conductor increases. What's meant by ohm? Ohm, it is the measuring unit of resistance, and the resistance is equal to the ratio between V over I. What does it mean? It means that if you have a resistance and its value is 1 ohm, and the current passing through it is 1 ampere, so for sure the potential difference between its two terminals is 1 volt, because 1 volt over 1 ampere is equal to 1 ohm. So what's meant by ohm? It is the resistance of a conductor which allows the passage or passing of electric current of intensity 1 ampere when the potential difference between its two terminals is 1 volt. Now we have a good summary in which we can just get as general rule that combines all the rules that we have studied till now. We said that electric current intensity is equal to the quantum charge divided by the time. And also we said that the potential difference is the ratio between the work done to the quantum charge. And according to Ohm's law, V is equal to I times R. So if you can just say red, and according to Ohm's law, I times R is equal to V. And for the first one, I times T is equal to Q. And for V times Q, it's equal to W, which is the work. If you just cover this side by your hand, you will get the first triangle, which is I times T is equal to Q. Also, if you just cover this side, you will get V is equal to W over Q, which is exactly this triangle. And finally, if you just cover this one, you will get Ohm's law, which is R is equal to V over I. And also you can get the units. The measuring unit of work is joule, the measuring unit of potential difference is volt, the measuring unit of quantum charge is coulomb, the measuring unit of electric resistance is ohm, the measuring unit of current intensity is ampere, the measuring unit of time is second. Let's answer some questions. A student has a resistor of unknown resistance. She places the resistor in series with the source of variable voltage. So now we have a battery of variable source. This it just like a slider, and she connected this source with the unknown resistance using a variable resistance, using a voltmeter, using an ammeter which is connected in series. So we need to connect it here She measures the current through the resistor at different potential differences and plots her results on the graph as shown in the diagram. What is the resistance of the resistor? So she measured the current from this ammeter and she recorded the value of the voltage from the source, because the voltage of the source will be exactly the voltage between the two terminals of the resistance, because this is the only component and the resistance of this ammeter is negligible, is 0. So the slope of this graph is equal to delta I over delta V, which is equal to the reciprocal of the resistance. So we need to calculate the resistance. So the resistance is equal to 1 over the slope. So we need to calculate the slope first, then we will reverse it. This is 1.6 minus 0 over, make sure that it's in ampere. This is 8 minus 0. Make sure that it is in volt. So it's 1.6 divided by 8. So it's 1 over 5. And the measuring unit is ohm per unit 1, by the way. When you just reverse it, you will get 5 ohm. So this is the value of the resistance. So the answer is B. For this question, consider the circuit below, this one. When changing the value of the rheostat, this is slider, so you can increase it, decrease it. Which of the following graphs represents the relation between RV and the reading of voltmeter? You see, this is the potential of the first point, which is A. This is the high potential because it's connected to the positive. And this is the potential of the other point, which is B, which is lower because it's connected to negative. The potential after passing through the ammeter is still A, because ammeter has very weak, very small resistor, which can be ignored. Here it's A. So this is B and this is empty wire, so this is B and this is B. Can you see? The reading of voltmeter, the voltmeter reads the potential difference between A and B, which is exactly the potential difference between A and B and A and B. So the reading of voltmeter will be equal to the electromotive force of the battery, which is a constant number. So the reading of voltmeter will be kept constant, whatever the value of this rheostat. Because when the value of the variable resistance increases, the current in the circuit will decrease. But according to Ohm's law, V is equal to I times R. Since R increases, R will decrease, so the potential difference will be kept constant. Okay, so what happens if you increase the value of RV? What will happen to the reading of voltmeter? It will decrease. Why? Because I is equal to V over R. V is constant. R increases, so the current will decrease. This is called inverse relation, and this is the representation of the inverse relation. This is wrong because this means that we have a physical quantity that increases with increasing rates, and it is not linear. This is wrong because this is a direct linear relation. This is wrong because it means that the reading of a meter will not change. No, the reading of ammeter will change. The reading of voltmeter is the one which will be kept constant. We have another question. Consider the circuit below. When changing the value of RV, the variable resistance, which of the following graphs represents the relation between RV and the reading of voltmeter? As we said before, this point has a potential. I will call it A. This point has a different potential, which I call it B. A, after passing by the ammeter, the potential will not change. This is an empty wire, so it will be kept constant. This will be the same potential as B, and also this one. So if RV increases, the current will decrease. If RV decreases, V stands for variable, I will increase. But in all cases, V is equal to I times RV, so V is kept constant. So as RV increases, what will happen to the reading of voltmeter? Nothing. So this is the correct answer. What's meant by the electric energy? Electric energy is the work done to transfer quantum charge between the 2 points having potential difference. This is exactly the same formula that we have used before for the potential difference. But in this time, we are talking about work. So work is equal to V times Q. So what's meant by electric energy? It is the work done to transfer quantum charge between 2 points having potential difference. So according to this triangle, we can just replace Q by I times T, or we can just replace V from Ohm's law by I times R. But we have I, so I times I is I squared R, and we have T. Or from this relation, we can just replace I from Ohm's law by V over R. So it will be V T. Then for I, we have V over R. So it's V squared T over R. So this is the relation that we can use to calculate the total energy, or this one, or this one, or this one, according to the given. What's meant by power? Electric power. Electric power is the rate of consumption of electric energy. So what's meant by electric power? It is the consumed electric energy within 1 second. The measuring unit of work or energy is joule. The measuring unit of time is second. So the measuring unit of power is joule per second or watt. So we can do the same. Power is equal to work over time. And we said that work is equal to V times Q over time. And according to this triangle, Q over T is equal to I. So power is equal to V times I. According to Ohm's law, you can substitute for I or you can substitute for V. If you substitute for I, you will put V over R. So you will have V squared over R. If you substitute for V, it will be I times R. So it will be I squared times R. So to calculate the power, you can use this formula, this formula, this formula, or this formula, or this formula, according to the given. How can we compare between the brightness of two lamps? If the lamp has more brightness, this means that it consumes more power. So, for example, if we have two lamps, this is the symbol of the lamp, but the two lamps, they have the same potential difference. They have the same V, for example, 10 volt. And this means that they are connected to the same source, right? So in this case, which one is the smartest? This is R1, this is R2. Which relation is the smartest one to compare between the brightness of these two lamps? Is it I times V, or is it I squared times R, or is it V squared over R? In fact, the smartest formula here is this one. Why? Because according to this relation, and according to the situation that we have, potential difference is constant. So this means that the lamp which has the lowest resistance will consume the maximum power. So power and resistance is inversely proportional in this case. So power is inversely proportional with the resistance on one condition. The voltage is kept constant. If the voltage is not kept constant, this relation is wrong. So power 1 over power 2 is equal to R2 over R1. You said you will see that no, it's not correct. You said here power 1 over power 2 is equal to R1 over R2. This is in another situation in which the current is the same. What if we have a light bulb and we have another light bulb? The current which is passing through the first lamp is 2 ampere, and the current which is moving through the second lamp is also 2 ampere, and this is R1 and this is R2. So what is the smartest formula to be used in this situation? Is it I times V? Is it I squared times R? Is it V squared over R? In fact, this one. Why? Because the current intensity is the same. So in this case, power is directly proportional with resistance, not inversely, directly, but on one condition, I is kept constant. So in this case, power 1 over power 2 is equal to R1 over R2. So this means that the light bulb which has the highest resistance will consume the largest power, so it will be more brightness. So this formula in case of constant current, this formula in case of constant voltage. Can you see? Power 1 over power 2 is equal to R2 over R1. This is case in case that we have constant potential difference. How can we connect resistors in series? if we have three resistors, this is the first resistance, this is the second resistance, and this is the third resistance. This is R1, this is R2, this is R3. Series connection is very simple. You just take the end of the first resistor and you connect it with the beginning of the second resistor. And you get the end of the second resistor and connect it with the beginning of the third resistor. Then you will take the beginning of the first resistor and connect it with the source. Maybe you can add a meter. And the other terminal you connect it with the end of the last resistor. This is called series connection. And as you can see in the series connection, all resistors, they have the same current intensity. So in the series connection, I is the same for all resistors. So if the current passing through this resistor is 1 ampere, then the current which is passing through all resistors is 1 ampere. But the voltage is divided among them. This is the reading of voltmeter. It reads the potential difference between the terminals of R1 only. This one reads the potential difference between R2. This reads the potential difference between the terminals of R3. If the value of this resistance is 10 ohm, so the reading of V1 is equal to I times R1. I is equal to 1, R1 is equal to 10, so its reading is 10 volts. If this resistance is 20 ohm, so the reading of the second voltmeter is I times R2. Why I, not I2? Because the same current is passing through the three resistors. So 1 times 20, it will be 20 volt. What if the value of this resistance is 40, for example? So the reading of voltmeter will be I times R3. So it will be 1 times 40. So it will be 40 volt. Can you see? V is equal to I times R. Since I is constant, V and R directly proportional, which means that the higher resistance will consume higher voltage, or will have higher potential difference between its two terminals. So in this case, to find the total resistance, you can do one of two things. First of all, you can divide the total voltage by the total current. And in this case, the total voltage is 10, 20, 40, so the total is 70. Divided by the total current is 1, so the total resistance is 70 ohm. Or you can just add them all. The value of R1 is 10, R2 is 20, R3 is 40, so the total resistance is 70 ohm. So in series connection, to find the equivalent resistance, what's meant by equivalent resistance? It is a single resistance which do the same effect of a group of resistors. It just equals the summation of all resistors, just like that. And this is the proof. Since V is equal to I times R, V1 is equal I times R1, V2 is equal I times R2, V3 is equal I times R3. So since the total voltage is equal to the reading of the first voltmeter plus the second voltmeter plus the third voltmeter, so I times R total is equal to I times R1 plus I times R2 plus I times R3. So we'll take I as a common factor from the right hand side. It will be cancelled with this I. So the total resistance will be equal to the summation of all resistors. This is in case of series connection only. This is the formula. What if we have equal resistors? For example, 2 ohm, 2 ohm, 2 ohm. So instead of adding them, we just take one and multiply by their numbers. So 2 times 3, it will be 6 ohm. This is exactly like the result that you will get from adding 2 plus 2 plus 2. The same. Let's answer some questions. Three resistors, 150 ohm, 50 ohm, 30 ohms, are connected in series. So one is connected after the other. 150 ohm, 50 ohm, and 30 ohm, and they carry the same current. The current intensity is the same, which are connected to a battery. Its electromotive force is 460 volt. Calculate the current intensity. How can we calculate the current intensity passing through the resistor? First of all, we need to calculate the total resistance. Total resistance is equal to the summation of the resistors because they are connected in series. So it will be 150 plus 50, it's 200 plus 30, it's 230 ohm. Now we have the total resistance and we have the total voltage, and according to Ohm's law, V is equal to I times R. So I is equal to V over R. V is equal to 460. The total resistance is equal to 130. So the total current is 2 ampere. This is the same current which passes through the whole resistors. So this is number one. Number two, the potential difference across each resistor. So if you connect a voltmeter parallel to each resistor, you can calculate the reading of each voltmeter. So the reading of V1 is equal to I, which is 2, times R1, which is 150, so it will be 300 volt. The reading of V2 will be I, which is 2, times V, which times R2, which is 50, so it will be 100 volt. The reading of the third voltmeter will be I, which is 2, times R3, which is 30, which will be 60 volt. Done. If you just add the three potential differences, you will get 460 volt, which is exactly equal to the electromotive force of the battery. In this question, the opposite figure represents three resistors X, Y, and Z, which are connected together in series. Then, which of the following graphs represents the ratios of the electric potential differences across them? As you can see, the same current is passing through the three resistors. So V is equal to I times R. And since they have the same current, so R and V are directly proportional. They will increase together and they will decrease together. So this means that the ratio between the potential differences is exactly like the ratio between the resistors. Or you can just write V1 is equal to 2 times I, which is R times I. And this one is equal to 4 times I. And this one is equal to 6 times I. You can just cancel I, and you can divide by 2. 2 divided by 2 equal 1. 4 divided by 2 equal 2. 6 divided by 2 equal 3. So the ratio is 1 to 2 to 3. So this is wrong. This is wrong. This is also wrong. This is right. Because as you can see, we have one line, we have two lines, we have three lines. So the ratio between them is 1 to 2 to 3. Two resistors 18, 12 ohm, which are connected in series. So one is connected after the other. It's 18 ohm, 12 ohm. So their equivalent resistance. The equivalent resistance is equal to their summation. So it's equal to 18 plus 12. So it's 30 ohm. So the correct answer is C. For this question, we have two resistors. Their values are 18 ohm, 12 ohm, which are connected in series, like we have done before, 18 ohm and 12 ohm. The potential difference at their ends that makes the total electric current passing through them is 1.5 ampere. So we can just replace these two resistors by one resistance. Its value will be equal to the equivalent resistance, which is 18 plus 12, which will be 30. And it will carry the same current. So now we have one resistor and we have current, so we can calculate the reading of voltmeter. So the reading of voltmeter will be I times R equivalent. 1.5 times R equivalent, which is 30, so it will be 45 volt. So this is wrong. The correct answer is C. We have another method of connecting resistors, which is called parallel connection. How can we connect resistors in parallel? If we have just three resistors, this is the first one, this is the second, this is the third, this is R1, this is R2, this is R3. We just connect all the inputs of resistors to one point, like this. And we will connect it with the battery. Then we will connect all the outputs of the resistors with another point. And we will connect this point to the battery. So in this case, the total current, this is the total current. When it comes here, this is called the branching point or junction, or it's called node, or it's called branching point. The current will be divided into three parts. This is I1, this is I2, this is I3. The sum of the currents on all branches should be equal to the total current. For example, if the current in this one is 1 ampere, this is 2 ampere, this is 3 ampere, since the total current coming out from this junction is 1 plus 2 plus 3 is equal to 6, so the total current is entering this junction is equal to 6 ampere. And also we have one current from the upper branch, 1 ampere from the upper branch, 2 ampere from the middle branch, and 3 ampere from the lower branch. So we have 6 ampere in total. So as you can see, in parallel connection, the current intensity passing through the resistors is not the same as in the series connection. But if the potential of this point is A, this is an empty wire, so this is A. Also, this is empty wire, so this is still A. A means the same potential and A. But after passing by this resistance, the potential will decrease. So it changed. So it will be B. This is an empty wire B. This is B. And this is B. Can you see? If we just add a voltmeter here between A and B, it will read the electromotive force of the battery. For example, 60 volts. So the potential difference between the two terminals of any of the following resistor will be also 60 volt because they are connected in parallel. So this is 60 volt, 60 volt, and 60 volt. And by using Ohm's law, we have the voltage and the current in each branch, so we can calculate the resistance of each branch. For example, we can calculate R1. R1 will be equal to V, which is 60, divided by I1, which is 1 ampere, so its value is 60 ohm. How can we calculate R2? Just by dividing V, which is also 60. The voltage is constant in parallel connection, divided by the current, which is 2, so it will be 30 ohm. How can we calculate R3? By dividing the voltage, which is 60, divided by the current, which is 3 ampere, so it will be 20 ohm. In this case, the equivalent resistance is not the summation. It is not the summation of all resistors. How can we calculate it? We can calculate it by V over I. What is the value of the total voltage? 60. What is the value of the total current? 6. So the total resistance is 10. As you can see, 10 is not the summation of all resistors, of course. And you are not required to calculate the equivalent resistance, but I will give you the formula. 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. For example, in the previous example, it was 60, 30, 30, and 20. You have 1 over 60 plus 1 over 30 plus 1 over 20 is equal to 1 over R equivalent. So 1 over R equivalent in this case is equal 60 to the power negative 1 is 1 over 60 plus 20 to the power negative 1 plus 30 to the power negative 1. So it's equal 1 over 10. So R equivalent is equal to, you will just reverse this one. You will find the multiplicative inverse. It will be 10 ohm. So it's exactly like the one that we have calculated here. This is called parallel connection. So in parallel connection, the voltage is kept constant, but the current is distributed over the branches. So if we have the total current is 10, and this is distributed over 4 branches, for example, what is the value of this current? Of course, it will be 10, because this is the total also. But what if this was 1 ampere, this was 2 ampere, and this is 3 ampere? What will be the value of this current? Of course, it will be 10 minus their summation. So it will be 4 ampere. So this is the parallel connection. And this is how can we calculate it. 1 over R equivalent is equal to 1 over R1 plus 1 over R2 and so on. But you are not required to do this. Okay. So in this question, the question is asking you just to calculate the total resistance and calculate the total current. So to calculate the total resistance, you are not required to do it, but I told you how to do it. 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So 1 over R equivalent is equal to 1 over 25 plus 1 over 70 plus 1 over 85. So 1 over R equivalent in this case is equal to 25 to the power negative 1 plus 70 to the power negative 1 plus 85 to the power negative 1. Then you can reverse it. So it's equal to 15.14 ohm to the power negative 1. Right? This is the final answer, by the way. So this is after I reverse it. So this is not ohm to the power 1, it's R equivalent, and this is the total resistance. Because if you want to calculate it from the beginning, 25 to the power negative 1 plus 70 to the power negative 1 plus 85 to the power negative 1, this is equal 1 over R. So to find R, you find its reciprocal. So it's 15.14 ohm. This is the answer of the first part. So I can replace these three resistors by only one resistance. Its value is 15.14 ohm, and it will be connected to the same battery in which its electromotive force is 45, and the same current will flow through it. So then we need to calculate the total current. The total current in this case is equal to V over R. V is equal 45, R is equal 15.14. So the total current is equal to 2.97 ampere. How can you calculate the value of the current in each branch? Simply, this potential difference is 45. So here the potential difference is 45. And also here, because they are connected in parallel. So the voltage is constant. So I will call this current I1, this current is I2, this current is I3. So I1 will be equal to 45 divided by 25. I2 will be equal to V, which is 45 divided by 70, which is the resistance. I3 will be equal to 45 divided by 85. So 45 divided by 25 is equal to 1.8 ampere. 45 divided by 70 is equal to 0.64 ampere. And finally, 45 divided by 85 is equal to 0.53. If you add these currents together, you should get this number if your calculations is correct. So you will add this number to 0.64 plus 1.8, which is very close. It's 2.969, which is 2.97. So we have calculated the current in each branch, and we have calculated the total current. We have a component which is called LED or LED or light emitting diode. This diode, its symbol is just like this, and this is its real image, just like a lamp. It comes in yellow, green, red, and sometimes blue colors. This is the positive one. This is called P type, and this is the negative one. This is called N type. This is the reason it's called PN junction, but you are not required to know this. If this device is connected to the battery in this way, so as you know, the current is flowing from positive to negative. So the current will flow in the direction of this arrow. Can you see? This represents an arrow. It's like a valve. It's like a one-way valve. So if the current is moving in the same direction, in this case, this is called forward connection or forward biased. In this case, this LED or light emitted diode will be turned on. It will be lighted, okay? And this is called forward biased. And its resistance is very low. It can be neglected. And it works as closed switch. So the circuit is on. But what if we have the same LED or light emitted diode or LED, but it's connected with the battery in the opposite polarity? So in this case, the current, of course, is moving from the positive to the negative, but as you can see, it is in the opposite direction of this valve. I told you this is like one-way valve. So in this case, the resistance is infinity, and this LED, it works as open switch, so the current will not flow. So as you can see, the LED is completely different from the bulb and the resistor. In the resistor, the current can move just from left to right or from right to left. It doesn't matter. But in LED or light emitted diode, it's just one way. It's just one direction way, or it's like a valve. It just let the current flow in one direction. Okay. So as you can see, if we have a LED and this LED is connected to a battery like this is the first situation. And if we have the same LED but it's connected to the same battery but flipped, and I will call this 1 and this 2. Can you see? As you increase the voltage, the current increases. This is called forward connection, forward biased. So which one is the forward connection? This one, because positive is connected to the positive of the battery and negative is connected to negative of the battery. So the current is flowing in the same direction of the bulb, so the current will flow. So as you increase the voltage, the current will increase. So this is 2. This is forward biased. As you can see, as you increase the voltage in the opposite direction, there is no current is passing through. Then this is called the breakdown voltage. This means that this diode is damaged. This PN junction is not working anymore. So as you can see, this represents 1 because this is positive, which is connected to negative. This negative is connected to positive. So the current is trying to move in the opposite direction of this bulb, of this LED, of this LED, of this light emitting diode. So this one is working as just open switch. So it will not let current to flow. So this is called IV characteristic graph for the LED or light emitting diode. What if we have a bulb? The bulb doesn't obey Ohm's law because when it works, its temperature increases. And we said that I is directly proportional to V on one condition, temperature is kept constant. So if I draw the voltage current graph for the bulb, it will not be straight line, it will be just curved line. And this curved line indicates that current increases as voltage increases. This is true, but it increases with a decreasing rates. What does it mean? It means for the first time it increased by 10 ampere, but the second time it increased by 6 ampere. The third time it increased by 4 ampere. So it's keep increasing, but with lower rates 2 ampere, then it is kept constant. What if you reverse the battery? So this is the symbol of the lamp. You connect it with the battery like this. Then you reverse it. What will happen? It will connect current. It will not prevent the current like the bulb did, this LED or LED, but the graph will be reversed. It will be flipped in the negative direction. So if this is number 1, this is number 1. If this is number 2, this will be number 2. So this is the IV graph for filament lamp. Its problem is that why the graph is not linear? Because as you increase the temperature, electrons will gain extra kinetic energy. So the number of collisions and friction between electrons will increase and the resistance of the bulb will increase. It's not constant anymore. As you can see, this is the IV for just resistance and the temperature is kept constant. But this is the IV graph for the filament of the bulb. And it is not uniform because the temperature is increasing. It is not constant. Finally, we have another device which is called LDR. L it stands for light, D it stands for dependent, R stands for resistor. The symbol of this LDR is just a box for resistance, but we have two arrows pointing to it because this is a variable resistance. Its value can be changed by light. This is the reason that it's called light dependent resistor. It means that a resistance that its value depends on the light. So as you can see, as light intensity increases, the brightness of the source increases, the resistance decreases. So there is an inverse relation between I. This time it is not current intensity, it is light intensity. This is called frequency. Inversely proportional with the resistance. So as the brightness of the light increases, the intensity, the resistance of the LDR decreases. and this is the IV characteristic for it. Can you see? I told you before the slope of IV graph is equal to 1 over R. So for having higher resistance, you should search for the smallest slope. This is the smallest slope. So the slope of the blue line is less than the slope of the red line. So this means that the resistance of the blue line is more than the resistance of the red line. So since the resistance is high, this means that the intensity of light is low. So the intensity of light in case of the blue one is low. As you can see, low light intensity, but here we have high light intensity. So as you can see, this graph represents that I and V, they are directly proportional. So this relation is linear and direct. But what if we have a relation between y and x, but it's just like this? It shifted upward. So this relation is represented by y is equal mx plus c. yc is the part that the graph intercepts with the y-axis. This is called, by the way, this is called linear relation because it is a straight line, but it is not direct. What if we have a relation between y and x, but it is represented by this one? This means that y increases by increasing rates as x increases. And by the way, this is maybe a second degree equation. For example, y is equal to x squared. This is not linear. This is not linear. This is called second degree equation. The second degree equation is just like this. But we are interested in its positive part, like this. What about this graph? This graph represents that y increases in a decreasing rates as x increases. So it is not linear, but y increases at x increase, but in a decreasing rates. What about this one? This means that x and y, they are inversely proportional. This means that y is inversely proportional with x. It means that as x increases, y decreases. This is very important. What if you have a battery? This battery is connected to 3 resistors. One of them is unknown. And the current passing through the 3 resistors is the same, of course. And the current is equal, for example, 1 ampere, maybe 2 ampere. And the electromotive force of this battery is equal to 100 volts. And the value of this resistance is 250. And the value of this resistance is maybe 150. And this resistance is called X. How can you calculate its value? First of all, you need to calculate the total resistance of the circuit by dividing the total voltage by the total current. The total voltage is 100. The total current is 2. So the total resistance is, so this one will be 1000. So 1000. Okay, so the total resistance will be 500 ohm. The 500 ohm is the total resistance of the 3 resistors together. So to find the resistance Rx, you need to find R equivalent minus the 2 resistors. So it will be 500 minus 250 plus 150. So it will be 100 ohm. Done. What if you have a voltmeter which is connected parallel to this resistor? How can you find its reading? Simply by multiplying I times R. So I is equal to 2. Its resistance is equal to 100. So its voltage is 200 volts. Done. What if we have the PN junction or the lead instead of connecting it to a battery, we connected it to AC source. But first, let's find out what is the difference between this one and this one. This one is called DC. This one is called AC. DC means direct current. AC means alternating current. DC means as time passes, the current is kept constant in intensity and direction. For example, 2 ampere, it will be 2 ampere all the time. But alternating current means as time passes, the direction and the value of the current changes in a sinusoidal wave. For example, if this is 2 ampere, this will be negative 2 ampere. And as you can see, as time passes, the intensity increases from 0 to 2 ampere, then decreases from 2 to 0, then increase in the opposite direction from 2 to negative 2, and so on. So the current reverses its direction every half cycle. This is what's meant by AC, alternating current. So for this one, this is the P type, which is positive, connected to the positive of the battery. This is the N type, the negative is connected to the negative. So the current is flowing in the same direction of this valve or LED. So the LED will be lighted up all the time, right? But here we have a problem. This source, its intensity and the direction is changed every moment, and its intensity, but its direction is changed every half cycle. For example, I will draw this one, I will copy it, and I will do it 2 times. Can you see? If we are talking just about this one, we will suppose that this one is positive and this one is negative. So this is the direction of the current. The direction of the current is in the same direction of the bulb. So this one will light up. So now this LED is on and it's switched on. But what if we just move to the other part? So the polarity will be reversed, because as I told you that this current is reversing its direction each half cycle. So the current in this case will try to flow anti-clockwise, which is in the opposite direction of this valve. So it will not allow it to flow. So in this case, the LED is turned off. So as you can see, if you just replace this battery with AC source, this LED will keep turning on and off. On and off. What is the reason? The reason is this AC source is called alternating current. What is the problem with it? It changes its direction every half cycle. So this is the reason that this LED will be turned on and off.